Welcome to Yoom'sClasses. Hello students. Here we are going to study about Rutherford's model of atom. So as you know already students, the Christmas pudding model, or also we call plum pudding model, given by J.J. Thomson, failed to explain certain experimental results associated with the atomic structure of elements. So another scientist, Ernest Rutherford, conducted an experiment, and based on the observations of this experiment, he proposed the atomic structure of elements and gave Rutherford atomic model. So this is the experiment conducted by Rutherford, and this experiment is known as alpha particle scattering experiment, or sometimes we also call gold foil experiment. So he conducted this experiment by bombarding a thin sheet of gold foil, as you can see here in the diagram, with alpha particles. As you can see here, alpha particle beam bombarding on the gold foil, and then studied the trajectory. Trajectory means different paths of the alpha particles moving. And in this way, he studied those different observations coming out of this experiment. So Rutherford directed high energy streams of alpha particle, that means beam of alpha particles, from a radioactive source. This is the source of that alpha particles, and this box is made up of lead, and inside this box only the source of radiation, that means from where the alpha particles will be allowed to come, is placed here in this box. So this is the source of radiation, and he placed a fluorescent zinc sulfide screen, detecting screen, around this gold foil, as you can see here, the green circular part, and he made certain observations which contradicted Thomson's atomic model. So when Rutherford carried out the experiment, his actual expectation was that alpha particles would be deflected by the subatomic particles in the gold atoms. Subatomic particles means protons, electrons, neutrons, etc. Since the alpha particles were much heavier than the protons, he did not expect to see large deflections. So this is the gold atom, and alpha particles are passing like this without deflections, without much deflections. So he made some observations from the experiment. Most of the fast moving alpha particles passed straight through the gold foil. As you can see here, most of the alpha particles, they travel straight, they passed straight through the gold atoms. Here one, here also this alpha particle moving straight, here also you can see. So in this way, most of the fast moving alpha particles, they passed straight through the gold foil. Some of the alpha particles were deflected by the foil by small angles. As you can see here, this is the example that an alpha particle moving with small deflection through the gold atom. Also, another surprising observation he could get, that is, 1 out of every 12,000 particles, that means alpha particles, appeared to rebound. As you can see here, this alpha particle is rebound back, and the reason for rebounding is because this alpha particle directly hits on the nucleus of the Gauss atom.
Happened to me in my life. It was almost as incredible as if you fired a 15-inch shell at a piece of tissue paper and it came back and hit you. Quote Ernest Rutherford, recalling the discovery of the nucleus.
Again, we can think of another activity to understand the implications of this experiment. Let us imagine that a blindfolded child were to throw stones at a barbed wire fencing and no sound would be heard. This is because there are lots of gaps in the fence which allows the stones to pass through them. As you can see here in the diagram, there are so many gaps between the fence wires. So if a blindfolded child has to throw stones through these fence wires, then most of the stones can easily pass through. As a result of that, the boy will not be able to hear sound. So in this way, in the Rutherford alpha scattering experiment, same thing happened. Most of the alpha particles, they could pass through easily through the Gauss foil since lot of spaces are present in the atom. So based on the observations, Rutherford concluded the following points. Most of the space inside the atom is empty because most of the alpha particles passed through the Gauss foil without getting deflected. Very few particles were deflected from their path, indicating that the positive charge of the atom occupies very little space. A very small fraction of alpha particles were deflected by 180 degrees, indicating that all the positive charge and mass of the Gauss atom were concentrated in a very small volume within the atom. So, finally, Rutherford could design a nuclear model of the atom based on those observations and conclusions. So, according to Rutherford atomic model, there is a positively charged center in an atom called the nucleus. Nearly all the mass of an atom resides in the nucleus. The electrons revolve around the nucleus in circular paths. The size of the nucleus is very small as compared to the size of the atom. So in this way, he could design the model of atom. Although Rutherford atomic model was based on experimental observations, it failed to explain certain things. Rutherford proposed that the electrons revolve around the nucleus in fixed paths called orbits. As you can see here in the diagram, this is the trajectory, this is the orbit where the electrons would revolve. So electrons would move with centripetal acceleration and energy would be radiated. So when the electrons move or revolve around the nucleus, they will move with centripetal acceleration and so energy would be radiated. As a result, energy would be lost. So the electrons would spiraling in to collapse into the nucleus. As you can see here in the diagram, the electron, after revolving, lose energy. So what will happen? These electrons, they will spiraling in, as you can see here in the diagram, and finally will fall into the nucleus of the atom. So atom would be highly unstable, and therefore matter would not exist in the form that we know. Okay, so students, let's have a small brainstorming session here. First question, what is the name of the experiment related with Rutherford's atomic model? Second question, why did Rutherford use foil made of gold? Third point, why did Rutherford use only alpha particles instead of using either beta particles or protons? Question number 4, which chemical was used in making fluorescent screen for his experiment? Fifth, what are the features of Rutherford's atomic model? So with this, we come to the end of this session. Thank you for watching.